are going to all we're going to do today is simplify radicals, square roots. Now, what I like about math is it tells you what to do. Okay, Zach, these are perfect squares through 100. You may need to know more than that. And why are they called perfect squares? Because if you draw a square, no, they're literally from the geometry. The area is a perfect square. It's a square, the area is 4. You can do a 3 by 3. Okay? Okay, Zach? That's a perfect square, 9. Because you can actually draw a square with these sides. Okay, so what does a square root mean? It means what times itself gives you 4. So if I square root this, these are matching. The square root of 16 is 4. Now this you should know, right? What's the square root of 121? 11. Okay.
Oh, 144 is 12.
That's right. And I had to know them all the way through 25. Okay, so how do we simplify square roots? First, let's get a little vocabulary. Okay, guys? A prime number is a positive whole number. Actually, it's redundant. We can just say it's a whole number because all whole numbers are positive. That means no negatives, no decimals, no fractions. And it's divisible by the number 1 and itself. So it has 2 divisors. Now, another word for divisor is factor. I wish they just called them divisors. But no, they have to invent a new word and call it a factor. Really, when you're asking to factor, you're asking to find the divisors. Okay, so the first prime number is not 1, it's 2. And the reason why it's not 1 is actually, it should say it has exactly, which means no more, no less, 2 factors. Okay, can't get this in there. 1 has only 1 factor, TJ, the number 1 in itself. So 1 is not prime. The numbers that have more than 2 factors are called composite. 1 is not composite either, because it doesn't have more than 2 factors. What's the next prime number? 3, 5, 7. Looks like it's going to be the odds, but it's not. Is 9 prime?
No, it's not prime.
9 has 1 times 9 and 3 times 3. It has 3 factors, 3 divisors. So 9 is not. 11?
Yeah, 15.
No, not 15. 13? No. 5 times 3? 17? 19? Okay. TJ, you should be taking some notes. So factors are whole numbers that you multiply together to get a product. They are divisors. I'm going to use the word factor. Okay, TJ? A radical, that's this symbol, that's a radical symbol, which means square root. You're going to see other radicals with numbers in here called an index when you go to higher algebra. The radicand is the number under the square root. So if I have the square root of 9, 9 is the radicand. Okay, just a little vocabulary, because if you don't know what the words mean when I use them, then you can't figure out what I'm doing. Okay, ready to simplify radicals? Okay, I want to simplify the square root of 48.
Okay. You do that.
I'm going to show you. First off, there's a property of radicals that if you have the square root of a times b, you can rewrite that as the square root of a times the square root of b. In other words, you can distribute that radical. Okay? A and b are the radicands. You can distribute it over the radicands. This is the radical. Can you do the square root of a plus b? Is that equal to the square root of a plus the square root of b? Girls? Are these the same? You'll try to make them the same, but they're not. Distributive property holds only for certain operations. It does not work for every single thing. Well, it's our fault because we just call it distributive property. I should call it distributive property of radicals over multiplication. That works. Radicals over addition does not work.
Excuse me, interruption. Is Ortega there?
No.
Not?
Okay. So, here's what I'm going to do. Hey, TJ, I'm going to make a list of the perfect squares on the side. Okay, shh. Okay, Zach? Those are my perfect squares. Now, I want the largest one, just perfect squares. There are a lot of numbers. 6 goes into 48, but that's not a perfect square, that go into 48. Obviously, it can't go to 49. It's too big. Okay, girls? Now, I could start by dividing by 36, but if you think about it, I only have to go half of 48. Nothing bigger is going to work. Let you think about it. But you could take your calculator and divide by all these numbers, and I want the biggest number that divides into 48 on this list. I'm going to show you 2 ways to do it. 25 doesn't go in. Does 16 go into 48?
Yes.
How many times?
3.
Okay, so the answer is going to be 16. Now, I don't write that down. I write this down. So this is 16 times 3. Okay? Now, because of my properties of radicals, I can rewrite this as the square root of 16 times the square root of 3. Okay, guys? And what's nice about math is it tells you exactly what to do. I can't do anything with square root of 3. I don't know what that is. But I do know what the square root of 16 is. What is it? It's 4. This will be replaced by 4 square root of 3. That's all you have to do. The number sense is remembering to divide by perfect squares, nothing else, and I want the biggest one that goes in there. But sometimes I don't pick the biggest one first. That is the answer. Now, does the square root of 4 times the square root of 3 mean any more to you than the square root of 48? No, I didn't think so. But we can figure out what the effect. I prefer the square root of 48 because I know that that's between 2 perfect squares. It's not equal to. Let's make it less than. Okay, so 48 is right here. It's between what 2 perfect squares? 36.
How to do this.
Well, this part you might have done. This is. Do you agree that that's true? But Friday we're going to order them, not today. But I at least want to get some idea how big it is. I know it's somewhere bigger than 6. Now, when you're taking the ACT, I did one problem on the right triangle thing without my calculator because I knew what the radical was, and I knew it had to be at least a certain size, and I knew it couldn't be bigger than the next answer. So I didn't get my calculator out. I just figured it out. Because time is important on the ACT. You have to get it done in the time you're given. That may be a challenge. So I know it's between 6 and 7. 4 square root of 3 really doesn't tell me, and I'm familiar with the numbers, doesn't tell me anything. But if I'm on my slide rule and I want to multiply that by something else, I want it in that form. Okay. Luckily, you don't have slide rules. So what if you choose, and I'm just going to go to the next page, what if you don't pick the biggest one? You can read what's on there. What if you choose 4? Because 4 is a perfect square. Is that going to get you in trouble? Not really. 4 times what? 12. I'm going to write my perfect squares here. I have them in front of me all the time. 16, 25. Okay, that's good enough. So this is the square root of 4 times the square root of 12. Now, I do write my perfect square first because some of you tend to just put that number, whatever it is, out in front. So if it's the one you can't square root, you mess it up. But if I read what it says, the square root of 4 is 2 times the square root of 12. We don't write the times sign. Now, is 12 simplified? Is there a perfect square in 12? Look at your list here. Here's 12. Do 9 or 4 go into it? 4. So guess what? You have to keep going until there's no perfect square left under the radical. Now, can I go ahead and go right to that step? It's 4 times 3. Are you okay with that? I could have written it, the square root of 4 times 3, and then written this. But after a while, I get tired of doing that.
What's wrong with just doing 12?
Because 12 still has a perfect square in it. Can't leave any perfect squares under the radical. So, what's the square root of 4? 2. These are all times. So this is 4 times the square root of 3. A lot of you want to say 4 to the square root of 3. That would be wrong. It's 4 times. Okay. One more way to do this. We can do a factor tree, but let me also show you how I do it in quadratic. I take 48, and I divide by the smallest prime number I can think of. In my other class, the quadratic, they want to take bigger ones. I said, oh, you can, but why don't we just do the smallest one? Smallest prime number is what? TJ? Would you read down, please? 2. 2 into 48 goes how many times? 24. This is cool. Now, I don't get the number sense feeling from this. Oh, a little bit, but not like I do the other way. But I will. This is a way, girls, that works every single time. This 2 still works, right? Keep going till you exhaust the 2's. Then you stop when the last one is 1. Now, here's what you do. If you have a match, it comes out. There's 1, 2. Here's another 2. It's all times. What's still underneath here, Zach? What's still under the radical? No. I pulled the 2's. They match. Those 2's match. What does not match? So this is 4 square root of 3. What I like about that is it works every single time. But I don't have the number sense. Now, I've been doing this for a long time. When I look at these radicals, unless they're really big, I've done them all, so I already know what they are. Now, for those who want to do a factor tree, maybe you recognize it, you do this. What two numbers give you 48, TJ?
12.
12 and 4. Now you keep going until they're all down to prime numbers, neither of which is prime. What do you want to do now? 3 times 4. Now, what I find is that students tend to just ignore the 4 that's sitting over there. You can't. It's still there. And, oh, by the way, what's 4? 2 times 2. Am I done yet?
No.
4 is 2 times 2. And this is, now you can't forget the other 2 times 2. And if you don't write it, it's wrong. If you just choose to not write that, because you say, oh, it's done, you still have to bring it down. Each one of these lines has to multiply to give me 48. And you may say, well, I know what it is. Well, the problem is you don't. You make a lot of mistakes. And if you are going to take, and some of you will take, the AP exam, and I'm a grader for the AP exam. And if you see math that's wrong, but doesn't really matter. Okay, I've seen this. And if I see this on the exam, even if they have the right answer, they don't get the point. You cannot write math that's wrong. This is fine, but I see students do this. Is that a true statement, TJ? If you're talking, you're missing what I'm talking about. I'm not going to talk much longer. We just have some problems to do. Is that a true statement? Not even close. I bet I've seen this on the AP exam. So they got the right answer, but it doesn't matter. They get the point for that, but I take it back because the mathematics is wrong. So you have to show the right mathematics. So be careful with your math. Now, I go back here and I match them up. Things that don't match, like the 3, they stay in the radical, but these match, so they get to come out. It's the same as doing it that way. But what's nice about this is, this is foolproof for the most part. You just have to do it. I don't care. Personally, I know that 16 goes into 48. That's the fast way to do it. So we got some problems here, like 72. 1, well, I shouldn't even write 1 because that doesn't matter. Let's see, 4, 9, 16, 25, 36, 49. I only have to go to half of 72, by the way. 64 and 81. Okay, so it's here. Somewhere between 8 and 9. And if I divide it by 64, it's certainly not going to work. Now you start here and go this way. What's the biggest perfect square that goes into 72? Zach, do you know? No, start here. 49 doesn't work. Does 36 work? Yes. Start with the biggest ones and go to the smallest. Then you will always get the biggest one first. So this is the square root of 36 times what? 2. So it's the square root of 36 times the square root of 2, and the square root of 36 is 6. It's not the square root of 6, it's 6. A lot of students want to leave the square root of 6. Why? Square root of 36 is 6. Just do what it says. It's when you make up your own math you get in trouble. Okay, Miles? You guys, put that away, please. And I don't know his name, so can't really call him. Okay, there's a bunch of problems here. Let's do those. I know what they are because I've done them all, although I didn't know 252.
Oh my gosh.
But the first one's easy. Let me write my perfect squares. I shouldn't even write one.
Which method is the best to use? If you have like 8,
Oh, 9.
I have 2.
Alright.
One's prime factorization, factor tree. Or guessing the biggest number that goes into this.
Don't.
So you start here at 25, and if you think about it, you only have to go half of whatever that number is.
We already know what it is.
So it's 9, right? So it's the square root of 9 times the square root of 3. What's that?
That's 3 times 3.
That's right. I have the answer on the board for 2. What's the biggest number that goes into 50?
25.
Yeah, this is the fastest way. But if you don't know what to do with that, 25 times 2, so it's 5 square root of 2.
Square root of 2.
Okay. Okay, get your calculators out. I have them here if you need them. Try 36 into 252.
This one.
Use your calculator. Do 252 divided by 36. Just divide it.
I got it.
This, I didn't know this one. It's 36 times 7. But all you have to do is divide by these numbers. Now, I would have done 4. And then I would have to do it again, that's all. So this is 6 times the square root of 7. We're almost done. How about 35? Do any of these numbers go into 35?
Oh, yeah.
Which one? Only the perfect squares. There aren't any. It's 5 times 7. That's all you can do. So you just leave it. Next one's easy. 11. This one's on the board too. What goes into 80? 36 doesn't, but you want the biggest one. 25 doesn't. 16 does.
16 goes into 30.
Use a calculator. 16 times 5 is 80.
4, 5, 8.
8 isn't the perfect square. 2 isn't the perfect square. Could you do 4? You could do 4 times 20. So that's 2. What perfect square goes into 20?
4.
4. See, why I like this is it gets you some number sense. You guys want to divide by numbers that are not perfect square. Only divide by the perfect squares. Put the list in front of you.
Why didn't you just do 35? That's
Because you can't do it. What perfect square goes into 35?
4.
4 doesn't go into 35. I don't know. Laura.
Are you okay?
Because it's 20. It's 20, not... Are you looking right here? Shh, guys. Yeah. 16 times 5. Oh, you don't keep going.
You already know.
What is the square root of 16? It's equal to 4. Is the square root of 16 equal to the square root of 4?
No.
No.
That would be 2 with that.
Okay, shh. It's when you want to do that, it's like saying 2 plus 3 is 5 plus 3 is 8. No, you don't keep going. You've used up that symbol. Okay, guys? Shh. This symbol says find the number you multiply by itself 2 times to get 16, and it's just plain 4. It's not the square root of 4. This number asks you to perform that operation. Find the number you multiply by itself to get 16, which is 4. Just like this plus. When you're done with 2 plus 3, you write 5 and you're done. You don't add it to anything else. You're done. You've used it up. Okay? And tomorrow we'll do that. Not tomorrow. Friday we'll do that. So now the question is, what kinds of questions do you have on the right triangle stuff? Okay. There's some opportunities here. Okay. Distance formula for 1. Okay, guys? I have new people here. You might have used the distance formula. I don't do that. It's a right triangle. How far apart are the x's?
Your mouse covers 9 apart.
9. Okay? 9 squared. Don't do 6 minus 3 or minus 3 minus 6 because you do it wrong. Okay? Get that out of there. Oh. Okay, guys? How far? Guys, enough. How far apart are the y's? 12. Now, you can use Pythagorean's theorem and figure that out. Multiply it out. Or you can recognize it's a 3, 4, 5 triangle. This is 3 times 3. This is 3 times 4. So the hypotenuse is 3 times 5. It's what? It's 15. Now, it makes it faster if you recognize what it is. Now, those who are new to me, and those of you who are not new to me, you still haven't mastered distance formula. It's how far apart are the x's squared plus how far apart are the y's. And you subtract them. But I don't want to show that subtraction because you tend to mess it up. So it's just easier to look at the number. Just do that. Because a lot of you will do this. D equals the square root of minus 3 minus 6 squared. That's wrong.
Yeah, I tried that. It didn't work.
Well, it's wrong. It has to be this. Well, that's too much work. How far apart are they? They're 9 units. Keep it simple. Okay, midpoint is just an average. She can do another one. I just, shh, guys, TJ, sit up here, please. Come on. You just average the x's. What is that when you average the x's? Okay, guys. Miles, what is it when you average the x's? TJ. Average them. You just add them up and divide them by 2. Everybody in here knows an average. 3 halves. Now you have ruled out this one, that one, and that one. You got a 50% chance. Laura, you want to do the y's? And then you can try the next one. It's also midpoint. Over. And do I need to finish it, really? It's 9 halves. Which one is it? There you go.
Yeah.
No, you are in a time situation.
Oh, really?
ACT is timed, yes. Can you guys find the midpoint now for number 3?
Let's do it.
You want to come up and do it?
I want to do it.
Then we got. She gets.
Plus 7 divided by 2.
Yeah. Write it down. Where's your packet?
It's 2.
Where's your packet? It's on your
A.
iPad. Write it down.
I know it's A.
So the x's are 10 apart.
Stop.
No, we're not finding distance. We're finding midpoint.
No, I have my Skyward lady wrote all your.
I don't know.
Yes, you do. You just average the x's. Yeah. Just add them up. Now, some of you were adding the x's to the y's. No, you add x's to x's and y's to y's. How'd you get 4?
Added them up.
And divide by 2. And lucky for him, 4, 4 was not an answer choice. So he would have said, oh, I made a mistake.
Lucky for me.
How about this one? Did you guys figure that one out?
No.
That one I thought was hard.
Did anyone actually do this?
Well, you had work time yesterday to do it.
Oh, I got that.
Okay. You guys, I want a rectangle. What has to be true about the angles?
Arrow.
I like to draw.
It's a rectangle. This is not a rectangle. It's true about the angles.
Or that was right.
We're just looking at that.
What kind of angles are they?
Oh, it's right.
90.
Right.
Triangle.
Okay, you could try to connect this. Shh. Guys, the door's there if you're going to chit-chat. You should have your packets out, or should have your iPad out, whatever you're working on. The only way I can draw it to get a right angle, even looking like a right angle, is right there. So I found the slope of that one, and I found the slope of that. Are they really right, perpendicular to each other? What's the slope of this one?
What?
DJ, how do you find slope? Now, you guys, slope is easy. I don't know why you make it so hard. We choose to put the y's in the numerator. Could have been the other way around, and it's only a number that tells you how steep it is. So this is 1, and this is -1. I do the y's in the numerator. In the denominator, I do the x's. 1 and 2 are partners, so 2 is there, and -1 is there. So the numerator comes out to be 2/3. That's correct. This is 2/3. What about the other one? Eric? What about the other one? Guys, the only iPad should be used for doing these problems. It's 1 minus a -5 over 2 minus 6. Well, some of you, maybe because it was towards the end of the exam, struggled on this piece. This is 6 over -4, which is -3/2.
Whoever final three.
They're graded in. They were graded a while ago. Okay. Look at what you're going to do here. I need to find this point, and the picture's pretty darn good. Miles, how are we going to find it? You're starting here. I'm going to use this slope. So what's going to happen with the y's? You're going to start at -1, and you're going to add, I don't want to add 6. I could do this, -6 over +4, because I don't want to go up. I want to go down. If I go down 6, where am I going to be on the y's? You will start it at -1. We're going to down 6. We're going to be at -7.
Whoa, that was good.
Then on the x's, you're going to start at -1 and go to the right 4. So where are you going to be? You're starting at -1, and you're going to go to the right 4. You're going to be at 3. Lane, put your phone away.
Or you could have looked at the answers and saw that x was over with -7.
True. Yes. Save you some time by looking at the answers after you get part of it. Those were the easy ones. You should be able to get that slope. Okay, you guys, do you know how to do number 6? Zach? Zach? Do you know how to do number 6?
Figure it out.
Okay, if you want to get the slope out of an equation, a linear equation, Eric, put that away, please. You need to have y equals mx plus b. Okay, ready? Guess what you have to do? Solve for y. How do you solve for y? Yeah.
You got y alone.
Yeah, how do you do that?
You have y alone.
So we're doing it right now.
What's it?
Minus 9x.
So then it's like,
You guys, if you just pay attention in class, the class is not that hard. Be careful.
it's not that hard. It's easy.
This isn't that hard. This is geometry. It's -9x plus 10. Okay, now, shh. Garrett, what are we going to do now? Guys. Guys, you're being rude. Not just to me, but to other people. Okay, what do you do now? Because you obviously don't know how to do it. Divide by -3. So I'm going to divide this by -3, this by -3, and this by -3. So I'm going to get y equals 3x minus 10/3. What's the slope?
10/3.
No?
3 over minus.
3 over 1.
What's the slope? Because everybody else said that? TJ said -10/3. No, I didn't. This is the slope. Okay, you guys, if you're planning on taking calculus, you've got to be able to do that. 100% accuracy. Not just little. Depending on what you want to major in, you might have to. If you go to Gustavus, St. Olaf.
Not going to school.
I'm just giving you, these are private schools. Shh, that's fine. Carlton, they don't have anything lower than calculus. And you have to take math. So,
How you point me up?
7, you're going to do the same thing. Zach, midpoint. Any of those schools, they don't start with anything lower than calculus. And if you do start with something lower than calculus, you pay for it, and you don't get credit.
Good thing I'll be taking calculus.
You want to take calculus. Okay, can you find the slope there? It's the same thing. Solve for y. What about, that's just distance. What about that problem? The answer is A. Did you get A?
Yes, you got it. I broke my brain on that.
Okay, how are you going to get that?
What?
How are you gonna get that?
And he's got wonderful work. How are you going to get it? Where's your work? Where's your packet?
I was writing it up.
Well, you have a yellow packet, or you have a you have it on Skyward or Schoology. Okay, let's get a plan.
I'll solve it.
This guy.
Okay, I want the shaded region. Okay, what are you going to do? Think of scissors here. I can find the area of the square, that's going to cause us problems, minus, how many triangles? 2 triangles.
No.
I read it too fast at first, so there were 3 triangles. No, there aren't. Colin, what's this shape? This is not a square. It's not a parallelogram.
Oh, it is that.
It has exactly 1 pair of opposite sides parallel. It's a trapezoid. It is. It's just on its side.
What?
Tell you what I'm going to do. I'm drawing it. I'm going to pull it out. And I'm going to rotate it. Oh, let's rotate it this way. There you go. Now do you see the trapezoid? No, it's a whole trapezoid.
Looks like a hill.
So, how do you find, you remember the formula for trapezoids? 1/2 the height times the sum of the bases.
Oh, yeah.
Okay. This base is x. This base is y. So I'm going to add those up. What is this side? X plus y. Okay, so the plan is find the area of the square. And it's a square. So if this is x plus y, guess what? This is x plus y. So it's x plus y squared. Do exponents distribute over addition? No. They do distribute over multiplication, but not addition. Then you're going to do what? 2 triangles? 2 times 1/2. What's the base of my triangles? It doesn't matter which is which. Base and height are what? X times y. Yes, but I double it. So guess what? The 2's are going to cancel. And then I ran out of space. Minus 1/2. The height is x plus y. And the sum of the bases is x plus y. And then you have to simplify that. And if you're clever, it's not that bad to simplify. I wrote mine all out. What is x plus y squared?
XY squared.
Nope. You have to multiply it. FOIL. X squared plus xy plus xy plus y squared. Did you know that, Zach? That x plus y squared is all of that?
I think I
12, draw a picture. Make sure it's quiet because you have to concentrate. It's really not that hard. And just think about it when you draw your picture. Put the A, B, C, D in the right places. Mark in the distances. You'll be fine. Oh, we know how to do this one. Do you remember what the formula for a circle is? Zach, what is it? It's x minus h squared plus y minus k squared. Come on up. Equals r squared. Who's going to do it?
This confusing me with this.
It's
The center with
15.
0 is just
0 is a number.
x minus 0 squared plus y minus 0 squared equals
Settle down.
Wait, it's gotta be
3 squared,
15.
4 squared.
Okay. Here's the origin. There's where it's centered. 3, 4 is right here, and this is going to be your radius. So this is 3, this is 4, this is 5. Now, right away you can rule out A without even doing anything. And you can rule out B because there's no squares. You don't know what to do with minus because I never taught you that. So you can throw that one out. So it's either D or E, but it's 5 squared. It's E.
You're wrong. Wait, what?
No.
What's, because it's R squared, not R.
Oh, dang, I read it wrong. It's B.
Yeah,
Oh,
no.
sure.
Yeah, but if you B is Y because you already did the square.
You can't.
And then
You can't. You cannot. If you have x squared plus y squared equals 25, that does not mean x plus y equals 5. Let's try it. If you don't believe me, 3 squared plus 4 squared equals 5 squared. That's 9 plus 16. That's 25. Is 3 plus 4 equal to 5?
No.
No, it doesn't work. So you cannot square root over a sum. You can't just do this. Because it's not true. I just did it. That'd be 3 plus 4 is 5. That's not true. So don't do that. Distributed property only holds for certain operations, not everything.
it would not 11, 12.
What?
Robbie, yeah.
12 is not that hard. You have all the up tomorrow. Now, on number 14, don't get disturbed by the picture. Just think of this triangle.
I was disturbed by the picture.
And it's just Pythagorean's theorem.
Oh,
This is the one that I did not use the calculator on. Because I said 4 squared plus 5 squared equals c squared. So 16 plus 25 equals c squared. So c squared equals, what's that end up giving me? 41? Okay, so c is the square root of 41.
Do we have any homework?
You have a work hour tomorrow. It's up to you. Now, you guys, shh, square root of 41 is between what two perfect squares? 36. Okay. So, sit down, guys. It's not time to go. It's not even close. No, it is. Actually, isn't. It wasn't even 11 when I last looked. No. That's why I'm doing this. Okay, you guys. Shh. Square root of 41 is between 6 and 7. Well, there's only one answer that's between 6 and 7. Can't be 3, can't be 3.3, can't be 6. You can rule those out because obviously it has to be bigger than 6. So it can't be 6. 6 isn't a right triangle. Has to be that. As I look through the answers, I'm only seeing, guys, sit down. It's not time to go. 2 really good answers. Now, 15, read that carefully. It's AG, not AC. I read it as AC, and I go, what? The answer's not there. Then you get a circle. Draw the picture on 17. It will become self-explanatory. And where did that picture come from? Somebody, they didn't like my picture. I like that picture better, actually. Draw the pictures. You've done 19 before. So tomorrow, you are going to work on finishing this up. Hey, I haven't dismissed you. And radicals. Yes, it's time to go. Okay, see you Friday, maybe.
See you, Mrs. G.
No. That's why I wanted to get through the stuff today.